Hi, my name is Michał. I'm a lecturer at City University of London, and I'll present PASSO, our privacy-preserving single sign-on system. This is a joint work with G, Licia, Alberto, and Etienne. So this work is about authentication. During the last 2 decades, websites evolved into sophisticated services that allow us to create accounts and store our data. So let's have a look at an example website. I can go to sign up here. So the classical way of authenticating is by providing a login and password combination. So the first time I go to a service, I have to choose a login and a password. It will be stored at the server side. And then every single time I connect to a service, I have to provide the same combination. It works, but it's difficult to manage as the number of services grows. Users end up reusing the same passwords, which poses multiple security concerns. An alternative approach is to use a single sign-on solution such as OpenID Connect at the bottom here. Here, users authenticate to an identity provider that will later authenticate the users to other services. In this case, we have GitHub, Google, and Microsoft come as identity providers. So let's go with GitHub here. I'm now being redirected to the GitHub website, which is my identity provider. I have to authenticate using my my login password combination. I click sign in, and then I'm being redirected back to the service. So this is done, and I'm being I can use my account. So how OpenID Connect works under the hood? The user first have to create an account with the identity provider. This account can contain multiple information such as age, gender, or country of residence. When user wants to connect to a web service, they send a request and specifies their identity provider. The web service asks the identity provider. The identity provider then asks for user's consent. And if it's granted, the identity provider will share user information with the web service. This is secured by asymmetric cryptography. The user is now authenticated to the service and can start using it. So there are multiple advantages of using OpenID Connect. First of all, now we have only one login password to memorize, which is much easier than memorizing multiple accounts for different services. Second of all, we have what is called intra-domain linkability. The web service always receives the global ID of the user, alice@idp.com here. So if the user tries to launch a Sybil attack by creating multiple accounts, the web service can easily detect and prevent it. We also have easy password recovery. So if the password is stolen or lost, the user just have to identify it themselves to the identity provider and can easily reset the password without going to multiple web services. We also provide accountability. Again, the web service has the global ID of the user. So if the user misbehaves, it is easy for the web service to act upon that. It is also easy to set up multi-device support. If Alice here wants to add a new device, say a mobile phone, it is enough for her to connect to the identity provider from the new device, and the whole system works as the initial device. OpenID Connect also works fully on the browser and does not require any additional software, and uses only simple cryptographic operation and is fairly fast. However, there are also multiple problems with privacy. The identity provider is the fully trusted party and can access users' data stored at the web service without users' consent or knowledge. Imagine that the web service is a hospital holding some medical records. You probably don't want your identity provider to have access to this data. Second of all, every time users connect to a web service, the web service must communicate with the identity provider. It leaves the identity provider with a full knowledge about the user activity. Furthermore, each service receives a global fixed ID of a user. So even if the identity provider fully protects our data, the web services can collaborate to profile users. Finally, the identity provides Finally, the identity provider is necessary for every login. If the identity provider is down, user cannot access any web service. It makes it difficult for smaller players to enter the market and increases web centralization. So can we do better than this? There are actually a lot of previous systems based on anonymous credentials. Anonymous credentials are based on zero knowledge proofs. The big difference here is that they require a private key at the user side. Users create a private key, and the identity provider issues credentials bound to this key. The credentials can be randomized for each login operation, which means that it's impossible to say whether multiple logins come from the same user or not. The users can also control the information they disclose and can prove claims. So a user can prove that they're above 18 without disclosing their actual age. All of this is really good for privacy protection. When we compare OpenID Connect against anonymous credentials, we can split their features into two distinctive groups. OpenID Connect struggles with privacy protection, but it's great for the ease of use, practicality, and accountability. On the other hand, anonymous credentials provide much better privacy protection, but are more difficult to deploy. First of all, we don't have intra-domain linkability. Users can randomize their credentials and create multiple accounts within one website, enabling easy Sybil attacks. We also don't have password recovery. User identity is bound to its private key. When the key is lost, the users lose access to their identity and all the services as well. There's also a problem with the accountability. The anonymous credentials protect users' identity, so it's impossible to punish users who misbehave. Furthermore, using multiple devices is complicated. Users have to manually export their key, securely migrate it between the devices, and then import it on a new device. Those operations are too complicated for regular users. Anonymous credentials require more sophisticated cryptographic operation, forcing users to install dedicated software. This opens a whole new Pandora box of issues related to interoperability. Finally, costly cryptographic operations produce significant overhead, increasing the logging time, especially in unconstrained devices. So in this work, we propose PASSO, which is a single sign-on authentication system that combines the privacy protection of anonymous credentials with the ease of use of OpenID Connect. We don't propose a new cryptographic primitives, but rather build a complete system around existing anonymous credentials. So this is how PASSO operates. As before, Alice starts by creating a single account at the identity provider. So we keep the one login password property. However, now she also creates a private key that is only stored locally and never shared with the identity provider. It makes it impossible for the identity provider to impersonate the user or access its data stored at the web server. The identity provider then issues credentials bound to the private key. When Alice now wants to connect to a website, she uses her private key plus the credentials from the identity provider to create a website-specific identity. Importantly, the web service can verify the validity of the identity without contacting the identity provider. We thus provide asynchronous authentication and protect user activity data from the identity provider. Now, when Alice wants to connect to a different website, say an online casino, she creates a new identity with potentially a different set of disclosed attributes. She can, for instance, only prove that she's above 18 to be able to play. The important thing is that the credential used across different websites cannot be linked to one another. So we achieve intra-domain unlinkability. PASSO forces users to create identities in a specific way, so that it's impossible to create multiple accounts, multiple Sybil identities for one website. We thus provide intra-domain linkability. Each identity contains also a hint about user real identity. It's encrypted and unavailable for the web service. However, if the user misbehaves, the website can leak it to some authorities. The authorities can then decrypt it and reveal the real identity of the user. We support threshold cryptography here. For instance, at least 3 out of 5 authorities must agree to the decryption for it to work. This provides accountability, but it's also an optional feature in El Paso. We implement El Paso as a WebAssembly module that runs fully in the browser and does not require any additional software. The web service simply points to the location of the module, which is automatically downloaded by the browser on the fly. This operation is fully transparent for the user. The module can also be cached by the browser, so we don't have to re-download it with every single login. The private key is serialized, stored in the browser built-in password manager, and automatically provided to the module. When user adds a new device, it's enough to log in with the new device at the identity provider. El Paso will automatically encrypt the existing key and send it to the new device via the identity provider. The key is only decrypted at the new device and never exposed to the identity provider. The procedure is transparent for the user and provides easy multi-device support. If the private key is lost or stolen, we provide the password recovery functionality. The user connects to the identity provider, reports the stolen key, and generates a new one. The identity provider immediately stops issuing the credentials bound to the old key to stop the attacker from accessing any services. El Paso creates now a special kind of credentials that will update the key information at the web services. This procedure does not have to be completed right away on all registered services. The replacement will happen automatically when user connects to a specific service. We thus achieve automatic key reset procedure. We compared El Paso performance against OpenID Connect and IRMA. IRMA is a direct implementation of classic anonymous credentials without additional procedure and requires installing additional software. All the tests were performed on a regular laptop. Not only El Paso achieves 4 times lower user perceived latency than IRMA, but also outperforms a certified implementation of OpenID Connect. We verified El Paso performance at the server side as well. We discovered that a single instance on Amazon AWS can handle up to 270 requests per second at the identity provider and more than 170 login operations per second at the web service. More results, including constrained devices, can be found in the paper. To conclude, El Paso is an asynchronous authentication system that combines privacy protection of anonymous credentials and practicality of OpenID Connect. Users generate domain-specific identities that are unlinkable across websites and can be verified without synchronously consulting the identity provider. El Paso automatically handles tasks that are traditionally difficult for the users and exposes a web interface that is similar to the one of the OpenID Connect. The efficient implementation lowers the user perceived login time and is lightweight enough to support hundreds of authentication requests per second on a regular server. Our code is available in open source. We have fairly good documentation plus a demo that you can play with. We also passed the PETS certificate evaluation, so the code should be good to go. So please feel free to have a look at our repository and reach us if you have any questions. Thank you.